if f of x is equal to ax squared plus bx plus c, meaning that it's quadratic, it's got that parabola shape to it, and we can factor it out, so that is a times x minus r times x minus s, okay? We want to show that the values of the derivative, okay, at r and s are negatives of one another, okay? So here's the picture. I'm going to draw the x-axis. I'm not going to put the y-axis on here because it's really irrelevant. But when we write something like this, f of x is equal to a times x minus r times x minus s, and we want to know where does this guy hit the x-axis. Well, we know that the y values are 0, so the function values have to equal 0, which means that x minus r is equal to 0 and x minus s is 0. So that means that when x is equal to r and when x is equal to s, we must cross the x-axis. Okay, so let's say here's r and here's s. Now, without loss of generalization, we can assume that r is before s. It really is irrelevant. Now, one of the things about a quadratic, okay, of a parabola here, is that there's symmetry involved. And so, if r and s are this far apart, then right in the middle has to be this symmetry, the line of symmetry, or the axis of symmetry for this particular parabola. Now, it could be going upward, it could be going downward, we don't know. But what we do know is that there's some symmetry involved here. Okay, so just for argument's sake, let's draw it in as if it's upward, so as if a is positive. Okay, so when I do that, I get this, right? Now, here's what the question's asking. It's saying, can you show that this line, the slope for this line, and the slope for this line are the same numbers except negatives of one another? So, for example, if this guy over here was m equals negative 2, then this guy over here would be positive 2. Or if this guy over here was negative 3/7, then this guy over here is positive 3/7. So we just want to show that the m values are opposite of one another. So in general, if m over here is equal to, let's say, I don't know, let's pick p, then this m over here is equal to negative p, right? Okay, vice versa. So we're gonna, first of all, you can see clearly because of the symmetry that that's probably a good conjecture, right? That looks like it's gonna be true. Now we need to prove it algebraically. So here's what we're gonna do. We've got the functions. Okay, and so we've got the function, I should say, f of x is equal to a times x minus r times x minus s. Okay, now what is f prime? What is the derivative? Well, the derivative for this guy, there's two ways to look at it. We can actually find the derivative of this in terms of all of this mess here, or we can look at the derivative of this because they're equal to one another. So remember that this is equal to ax squared plus bx plus c. So, but let's actually go ahead and let's take a look at this guy and let's find its derivative. So the derivative here should be equal to the function evaluated at x plus a little bit minus the function evaluated at x all over a little bit. And so, of course, what we also have to put in here is that we want that little bit to become really small. Okay? So let's go ahead and take this guy and plug it in here. So we would have a times x plus delta x minus r times this right here is going to be x plus delta x minus s. Okay. Then we have to subtract off the function, which is a times x minus r times x minus s. And this is all over delta x. So we actually have to do the multiplication out here, and it gets kind of ugly here, so I'm just going to make sure that I stay consistent. So this is going to be a times, you know what, we still might not have enough room, but I am going to drop this down over here so that we can maybe fit all of this on the same screen. So it's going to be a times quantity. I got to FOIL this ugly mess out here. So I've got x squared plus x delta x minus s x plus x delta x plus delta x squared minus well, where am I? S delta x. There we go. Okay. And then the last one is minus Rx. Okay, so minus Rx minus R delta x plus Rs minus. Now we got to do this. So this would be ugly. Not too bad. Minus a times. So it's going to be x squared minus Rx minus Rs. Excuse me, not minus Rs, minus S delta x, or excuse me, minus Sx plus Rs over delta x. So let's see what we can combine up here. We've got x squared, but there's really no other x squareds in there. So here's what I've got. I've got a times x squared. I'm going to cross things off as I use them. Okay, I've got an x delta x, an x delta x, an s delta x, and an r delta x. And so if I put all of those together, okay, it's going to be plus the quantity 2x, right, because I've got an x and an x, so two of those guys, minus an r, right, minus an s, so minus r minus s. Okay, so that is going to hit, oops, I think I said that wrong. Let me go back and restate that. There's a lot of variables floating around, so you got to stay consistent. So here I've got an x delta x, an x delta x, a minus, and a minus. No, I think I said that right. So it's going to be 2x minus s minus r minus s. It's really irrelevant, times delta x. So that's going to drop out this guy, this guy, this guy, and this guy. And so all that's left now is we've got a minus sx, a minus rx. So that drops these two guys now. We've got a plus rs. And then we also have a plus delta x squared. And that's minus a times x squared minus rx minus sx plus rs. Okay, and that's all over delta x. So, if I multiply my a in, okay, and actually I'm going to move some stuff around here. So look, it's going to be, let's move this up. This is going to be ax squared plus 2ax minus 2ax delta x. And put this back into here because I'm going to see it's going to cancel over here. So minus sa delta x minus ra delta x. That takes care of this. then minus SAX minus RAX plus RSA plus A delta X squared minus AX squared. We're going to run out of room here. Minus ARX minus ASX. Whoops, this is going to be plus, so I got to rotate those signs. This is going to be, let's see here, this guy's going to be plus, this guy's going to be plus, and this last guy here is going to be minus. So minus ARS, and that whole thing is over delta X. So let's see what cancels here, because there's going to be a bunch of things. So AX squared and AX squared. I've got a positive ARX and a negative ARX. I've got a negative SAX and a positive SAX. And then I've got a positive RSA and a negative RSA right here. See, told you a bunch of stuff was going to cancel. So what are we left with? 2AX delta X minus SA delta X minus RA delta X plus A delta X squared over delta X. And if we get rid of the delta X's, we're left with 2AX minus SA minus RA plus A delta X. Now again, where'd it go? This guy is going to be, delta X is going to be really small. So when delta X is really small, that means that f prime of x is going to be equal to 2ax minus sa minus ra. It's not the answer, okay, but that is the slope of the tangent line. Now watch. This is going to be the cool part. Hopefully. I haven't done this problem yet, but we'll see how it works. When x is equal to r, that's this guy. The slope of that line is given by this equation. So f prime, when x is r, then that's equal to 2ar minus sr minus r squared. And so that, guys, there's really not a whole lot, right, that I can do with that. Okay, it's pretty much stuck. Now let's look at f prime. So that's the slope of the tangent line. It's ugly, but that's the slope of the tangent line. Now let's look at f prime of s. Well, f prime at s is going to be 2as minus s squared minus rs. Now, what have we got here? Well, if you take a look here at these values, hang on one second. Excuse me, I messed this part up. I plugged it in for all the a values and not the x values. So let's go back and relook at this. That's going to be f prime of r is going to be equal to 2ar. You know what, we can actually, if you want to, we can factor out an a in this right here. And so we get 2x minus s minus r. So this over here, just trying to make this look a little bit better than what it was. This over here is going to be a times 2r minus minus s minus r, and this is going to be a. This is going to be 2s minus s minus r, like that. And so if you go ahead and do some simplifying here, the first one becomes a times 2r minus r is r, so this becomes r minus s, and this becomes a times, now we've got 2s minus s, this becomes s minus r. And so if you look here, the two slopes, this is the slope at r, so the slope at r is a, the slope here of this line is a times r minus s, and the slope of this line here is a times s minus r. Okay, and so if you take the green one and you were to pull out a negative, you'd have this. And so we can rewrite this as this right here. And clearly this, so look, this point, this guy right here is the same as this guy right here. And the only difference is there's a negative up in front of this one. So these guys are exactly what we're looking for, opposites of one another.